Alright, good morning and welcome to Master Talker online class. Today we'll be talking about a topic that is called ellipse. Okay? And how do you know an ellipse? Ellipse look like a circle, but how do you know an ellipse? An ellipse is defined as the locus of all points x, y, such that the sum of the distance from two fixed points called foci, okay, is a constant. You know that the singular of foci is focus. So focus, because they are two, you have foci. So that is that. So I'm having this. This is the fixed point. These are the two fixed points I have. Anywhere you stand on this circumference, let me call it circumference, okay? To those fixed points, if you add both of them, they will give you a constant 2a. That is when you say that what? That shape is an ellipse shape, okay? Now, there are things you need to know about ellipse. The center of anything, remember the center of a circle, we use it as what? H comma k. So the center of this ellipse is equally h comma k. Don't forget that the center of a parabola is the vertex. So that is why the vertex is h comma a. But here it's not so. The center of this ellipse is h comma k. Why the vertex? If you call it va, so you are adding or subtracting a. So the vertex of a parabola of an ellipse is what? Depending on where the ellipse is parallel to. If you see that this ellipse is standing horizontally, so it's parallel to x axis, so we are adding anything to h side. So if you say vertex va, you are adding a sound like a, so you're adding a to the side of x, which is h, and subtracting from the other side. So the vertex of an ellipse is simply v in bracket of what? H plus or minus a comma what? K. Okay, so I will still tell you the formulas. So now for the focus, okay, or the foci, so I'm adding the chi, the c there. So are you getting it? So for the foci, you are adding or subtracting what? C to the side of what? X, because it is facing x. So you say what? H minus c for the left hand side, comma k, and h plus c for the other side. Now we are going to derive, in this video we are to derive the equation of what? An ellipse. Okay, if we derive the equation of an ellipse, I'll give you the formula, so that in the next video we'll now start solving calculation. Now look at what they told us. Let me call this place d1 and d2. Okay, let's get our d1. D1 is equal to, the distance between 2 points. The first one minus this all squared. So d1 squared will be what? X minus what? H minus c, okay, all squared, plus y minus k all squared. Okay, so x will subtract the side of x and y will subtract the side of y. So you remember that h and k always stay together. So my d1 is equal to the square root of, now let me put them together. I want x minus h to be together, then minus will clear this to become plus. Okay, so I'm having plus c all squared, then plus y minus k all squared. Okay, so this is my d1. Okay, let me get my d2 and know what my d2 will give me. My d2 all squared should be equal to the same thing, x minus the side of x. So x minus the side of x is h plus c all squared, plus y minus the side of y, which is y minus k all squared. So if I clear this, I'm having that d2 is now the square root of what? Let me bring them together. X minus h, then minus c, because minus this, minus this, minus. So I'm having all squared plus y minus k all squared. Now, if we claim that this thing is an ellipse, it means that if I add d1 plus d2, I am going to get what? 2a. That is what the formula said. Okay, so from this place now, let me clean the board and then let's start the derivation. Okay, so I'm having that d1 plus d2 is equal to 2a. So what is my d1? My d1 is the square root of x minus h, sorry, this is x minus h. Okay, sorry, look at what I'm, x minus h plus c all squared, yes, plus y minus k all squared, okay, plus my d2. Permit me to clean here because it's a long equation. d2 is what? The same thing, x minus h, this one, minus c all squared plus y minus k all squared, and they say is equal to what? 2a. Okay, now the next thing you are going to do is to square both sides. But like I taught you in a sword, that two swords cannot be in one place, you square both sides. So I need to carry one of them to the other side. So I'm having the square root of x minus h plus c all squared plus y minus k all squared, okay, is equal to 2a minus, because it's plus, if it comes to this side it becomes minus the square root of x minus h, okay, minus c all squared plus y minus k all squared. So now let's square both sides. Square both sides. So if I square both sides, I'm having the square root of x minus h plus c all squared plus y minus k all squared, and we are squaring the other side. 2a minus the square root of x minus h minus c all squared plus y minus k all squared, then all squared. Okay, so let us clear this. Okay, clearing this, I'm going to have now square will cancel square root, so I'm left here with x minus h plus c all squared plus y minus k all squared. Okay, now this is two things, and I told you if you have a plus b all squared, or a minus b rather all squared, the answer is square the first one, I'm having a squared, multiply the first one and the second one, double it, I'm going to have minus 2ab, then square the last one plus b squared. So that's what we're going to do here. So thank you. So let's do that. If I square this first one, I'm going to have 4a squared. Now multiply these two things and double it. This time this, double it, I'm going to have minus 4a, then the square root of x minus h minus c all squared plus y minus k all squared. Now I have doubled it, so the next thing is now to square the last one. If I square this last one, square root will cancel square, and the square of minus will give you plus. That's why I'm having plus here. So plus x minus h minus c all squared plus y minus k all squared. Okay, so since I have this, if you look at this very well, you see that this one will take care of this one. Okay, yeah, so I'm left with these two, and these two are the same. If you look at these two things, are they the same? Okay, no. Let me open this and open this. Let's see what will cancel out first. Let's open this. If we open this, I'm going to have square the first one again. I'm having x minus h all squared. Use the first one, multiply the second one, double it. I'm going to have plus 2c bracket x minus h plus what? C squared. Okay, I've gotten this one. Okay, is equal to 4a squared minus 4a the square root of x minus h minus c all squared plus y minus k all squared. Okay, now then let's open here as well, plus square the first one here. I'm having x minus h all squared, multiply the first one and the second one, double it. I'm going to have minus 2c bracket x minus h, then square the last one. I'm going to have plus c squared. So c squared will cancel c squared, x minus h all squared will cancel x minus h all squared. So I am left with how many things? 1, 2, 3, 4. Okay, so now let's continue from here. So if you look at that thing very well, okay, if you look at it very well, you are going to see that these two things are the same thing. So let me bring this one to this side. Okay, in fact, let me bring everybody without squared one side. So let me carry this one that has squared minus and bring it to this side so it will become plus. So if I bring it to this side, I'm going to have 4a, okay, the square root of 4a the square root of x minus h minus c all squared plus y minus k all squared. Okay, that is this one. I brought this one to this side, but the other side is equal to, I already have 4a squared here, okay, and which other thing ahead? I already have minus 2c bracket x minus h here, okay, then this one is plus 2c, going to the other side to become another minus 2c bracket x minus h. Okay, so now look at this. I'm going to have 4a the square root of x minus h minus c all squared plus y minus k all squared, okay, is equal to 4a squared. Now these two minus this will give you minus 4c bracket x minus h. Okay, now if you see that everybody has c has 4, I can divide everybody by 4. Divide through by 4. Okay, thank you. So I can divide everybody by 4. So if I divide by 4, divide through by 4. If I divide through by 4, I'm left with a here. A the square root of x minus h minus c all squared plus y minus k all squared, okay, is equal to a squared minus c into x minus h. Okay, so this is what I'm left with. Now let me square both sides again to remove this square root. Square both sides. If I square both sides again, I'm going to have this side now a the square root of x minus h minus c all squared plus y minus k all squared is equal to what? A squared minus c bracket x minus h everything squared. So now let's do that. Okay, sorry, squaring both sides. Now first thing, a squared, a is not inside this square root, so a squared will give you a squared. Now square will cancel square root, so I'm left with x minus h minus c all squared plus y minus k all squared. I'm left with this. So because square has cancelled square root, is equal to, let's do the same thing again. Square the first one, a raised to power 4. Multiply the first one and the second one, double it, minus 2a squared c bracket x minus h. Then square the last one, I'm going to have plus c squared bracket x minus h all squared. Okay, so let me open the bracket with this okay, let me open here. Let's open inside here. So I'm still having a raised to power of a2 here, a squared here, in bracket of opening this one, square the first one. I'm going to have what? X minus h all squared. Multiply the first one and the second one, double it, minus 2c bracket x minus h. Now square the last one, plus c squared, okay, then plus y minus k all squared, then is equal to the same thing here, a4 minus 2a squared c x minus h plus c squared bracket x minus h all squared. So as simple as that. Now since everybody is open, now let me now open everybody with this a squared. If I open everybody with a squared, I'm having a, or let me write it up here. If I open everybody, so a squared times the first person, I'm having a squared bracket x minus h all square. A squared as the next person I'm having minus 2a squared c bracket x minus h. Okay, a squared as the next person I'm having a squared c squared. A squared as the last person I'm having a squared bracket y minus k all squared. Okay, is equal to, so I'm left here with a raised to power 4 minus 2a squared c bracket x minus h, then plus c squared bracket x minus h all squared. Okay, so if you look at this, you will see that this one will cancel this one because they are the same minus, they are the same thing. So any other person that can cancel? No. So let me collect like terms. If I collect like terms, I'll see that this person has x minus h and another x minus h. So come here. So I'll have what? A squared bracket x minus h all squared minus c squared bracket x minus h all squared. Okay, plus, let me leave this one, a squared bracket bracket y minus k all squared is equal to, this one is already a raised to power 4. This is a constant, it doesn't have y. Go to the other side, minus a squared c squared. Okay, so now let us factorize. There is something that can factor out. Let us factorize. If you look at this place, you see that they have x minus h all squared in common. So if you bring out that x minus h all squared they have in common, so they are left with a squared minus c squared. Okay, plus a squared bracket y minus k all squared is equal to, they have a squared in common. So if you bring out a squared in common, so they are left with a squared minus c squared. You see that? So now in ellipse, equation of an ellipse, okay, in ellipse, c squared is equal to a squared minus b squared. Okay, is it minus or plus? Yes, a squared minus b squared, because in the equation is plus. Okay, so because we are adding the difference of we are adding the two distance to get 2a. That is why the c squared will have minus. But in hyperbola, you are going to subtract the two distances. So in hyperbola, c squared will not be plus here. We are still coming to that. So if I collect like terms to get that, I want this man, I want to know what b squared will give me. Let this man come here, let this one come here. Okay, so if this one go here, this implies that what? B squared going here is equal to a squared is already here. This one will come here, minus c squared. Okay, so that is that. So anywhere I see a squared minus b squared, I'll put what? A squared minus c squared, I will now put what? B squared. So I'm having, let me write this one first as b squared bracket x minus, or let me just write it very so you don't get confused. So this is x minus h all squared b squared plus a squared bracket y minus k all squared is equal to what? A squared b squared. So now let's divide everybody by a squared b squared. Divide by a squared b squared. So I'm going to have x minus h all squared b squared all over a squared b squared, okay, plus a squared bracket y minus k all squared all over a squared b squared is equal to a squared b squared over a squared b squared. Okay, so if we have this, we see that some things can cancel out. So what and what can cancel out? This can cancel this, this one can cancel this one, and this one cancel this. So I'm left with x minus h all squared over a squared plus y minus k all squared over b squared is equal to 1. So this is the equation of an ellipse. And note that b is always that a is always greater than b. Note that a is always greater than b. Okay, now and then equally note that what? Don't forget that what? That c squared is equal to a squared minus b squared. Okay, so what am I saying? This is what? An equation of what? An ellipse that is parallel to x-axis. How do we know that this equation is an ellipse? 1. How to know equation of an ellipse? 1. The coefficient of x squared and y squared, okay, will be the same in size, in sign. That is, if it is minus, it will be minus, but they cannot be the same coefficient. Okay, for example, now if you have minus 2x squared plus y squared plus 2y squared plus blah blah blah, if you look at this now, it is 2 here, but their sign are not the same, so it's no longer an ellipse. An ellipse said the sign must be the same, but the coefficient will not be the same. So if it's plus plus like this, it is not an ellipse, it is now a circle. So the difference between a circle and ellipse is that the coefficients are not the same. The coefficient are the same. If here is 2, here can be 3 or 1 or anything, so the coefficient will not be the same, but the sign must be the same. Are you getting it now? But in hyperbola, the hyperbola said only that the sign will not be the same. Even if the coefficients are the same, it's not your problem. So just know how you differentiate it. A circle is that they will be the same in every aspect, both in the number there and in the sign. But in hyperbola, in ellipse is that what? That the sign alone will be the same, but the coefficient, the number beside it, will not be the same. Then in hyperbola, only the sign will not be the same. Every other thing can be the same. So please note that. So the first equation of a parabola, the first way to know an equation of a parabola is that what? That the sign will be the same, but the coefficient will not be the same. Then there will be no any place you have x and y together. So that is that. So this is an equation of a hyperbola, an ellipse. Sorry. How do you know that this ellipse is parallel to x or y axis? If the coefficient, if the denominator, okay, or let me say, if the coefficient of x is less than what? The coefficient of y. That is the first method to know. If the coefficient of x is less than the coefficient of y, then it is parallel to what? X axis. The side with the smaller coefficient. And you know that if the denominator of something is big, it means that that thing is small, because the bigger thing is dividing it. So another method to know is that if the denominator of that x is bigger than the denominator of y, then it means that it is smaller. So which means it is parallel to x axis. So thank you very much for watching. In the next video, we'll talk about the formulas that are attached to ellipse, and then we'll solve calculation. God bless you.